Hey guys, so here's part 2 of the 7.2 notes. We're graphing exponential decay functions. Okay, so now if we look at our new function, we have y equals negative 2 times 1/3 to the x minus 3 power plus 2. So here we notice we have our h and k. So remember the general form for our absolute values. We have a times b to the x minus h plus k. So remember, h we move horizontally and k we move vertically. So h means that we move to the left and right. K means we move up and down. Okay, so you might need to write that back down again if you need to. So let me write this. So a times b to the x minus h plus k. Remember, a, it tells you if we have a vertical stretch or shrink. If a is negative, there is a reflection, and a is your y-intercept. Then h, if we have, let's say, x minus h, we move to the right. And you don't necessarily need to write this down again because this is the same idea when we talked about in 7.1 with our transformations. If we have x plus h, we move to the left. And if we have a positive k, that means we move up. Negative k, we move down. And don't forget your k, it affects the asymptote. Okay. Okay, if you need to pause the video to write all that down, if you need to again, you can. But we're going to go ahead and go on to graphing the other. Okay, so when we graph and we have h and k, remember we graph the parent function first. So that's going to be just our a and b. So I have negative 2 times 1/3 to the x. Okay, so graph parent function first. So now you can plug this into your calculator. I go from negative 2 to positive 2. And let's see what this looks like if we plugged it into our calculator here. Okay. So I have, whoops, I want it that big. Negative 2 times 1 divided by 3, then to the, and then I do negative second power. We get negative 18. Okay, now I do the next one. So I do negative 2 times 1/3 to the first, which we kind of should already know that's just going to be 2/3 or negative 2/3. Okay. Okay, if we take our to the 0 power, remember 1/3 to the 0 gives us 1. Negative 2 times 1 gives us negative 2 there. And then from there, doing with the 1, that gives us negative 2. So we flip it. Oops, I think I switched this because I did it to the negative or to the first power. That should be negative 2. There we go. This will be, sorry, let me redo with the negative first power because we have to flip the fraction because I did it to the first power. That was my mistake. Okay, so negative 2 times 1/3 to the negative first power. Now that flips it, so we'll do negative 2 times 3 to give us negative 6. That makes more sense. And then to the second power, that's basically negative 2 times 1/9. So that gives us negative 2/9. Okay, I first draw my asymptote at the default of y equals 0. I graph these points to negative 2, down negative 18. That's kind of off the graph. I'm not going to really graph that. Now, negative 1, negative 6. There we go. And then 0, negative 2. And then I have 1, negative 2/3. And boom. So now I connect Now remember, because we are going to be doing two graphs here, you can either do two different colors, or you can do one that's dotted and then one that is solid to represent the two different graphs. Now we are going to take our translations and move our points. So with the x minus 3, remember that's our h, here's our k, we are going to move right 3 and up 2. So each point I'm going to move to the right 3, up 2. So going over, I'm going to go over to the right first. Over 1, 2, 3, up 1, 2. Over 1, 2, 3, up 1, 2. And these over 1, 2, 3, up 1, 2. 2, 3, up. There we go. Now, remember, the k value is the one that affects our asymptote. We are now at y equals 2 because I have to move my asymptote up 2. So now I connect my graph. Boom, boom, boom. There we go. And now let's go ahead and do the domain and range of our blue function here. So any exponential is negative infinity to positive infinity. Our range, now our asymptote's at 2, but notice that our graph is below the asymptote. So that means we are decreasing there. So going from negative infinity to our highest value, which is not really included, but it's up to 2. Okay, so now let's kind of just make sure we know when we have exponential growth and exponential decay functions. So I would like you guys to go ahead, pause the video, and tell whether the function shows exponential growth or exponential decay. So go ahead, pause the video, and do A, B, C. Okay, let's see what you got. So remember, if our b, and we do y equals a times b to the x. So b is greater than 1, that is a growth. If b is in between 0 and 1, that is a decay. So for a, our b value is 3/4. Well, since 3/4 is in between 0 and 1, this is a decay, exponential decay for a. Okay, let's look at b. So our b here is 5/2. Now be careful. Yes, it is a fraction, but is 5/2 in between 0 and 1? No, it's actually greater than 1. Okay, so our b value is greater than 1. So this is actually a growth here. Okay, then our last one. Our b is 0.25. That is in between 0 and 1. So this is a decay. Okay, make sure you guys work on the homework assignments, and if you have any questions, make sure you contact me. I'll see you guys later.